Our universe is a magnificent tapestry, woven from countless galaxies. Each one unlike the last, different in form, different in scale. Some are colossal beyond imagining, stretching millions of light years across. Others are delicate and faint, like the barely there shimmer of a distant star, caught in a corner of the night sky. Today, we embark on a journey across the cosmos, visiting 10 of the most iconic galaxies the universe has ever formed. We hope this voyage washes away the weariness of your day. Are you ready? Then let us set sail on an adventure across billions of light years. In an instant, we are transformed, crossing millions of light years in a single breath. Our first destination, the Andromeda Galaxy. At roughly 2.54 million light-years away, Andromeda is the largest spiral galaxy nearest to the Milky Way, its disk spanning approximately 220,000 light-years across. Within it dwell a staggering number of stars. Scientists estimate at least 1 trillion, several times more than our own galaxy. Andromeda is renowned for its elegant spiral arms, its luminous central bulge, and its active core, where a supermassive black hole, equal in mass to 140 million suns, quietly holds dominion. In the early 20th century, humanity still believed Andromeda was merely a cloud of gas within our own galaxy. Then, in 1926, Edwin Hubble observed Cepheid variable stars within it and proved for the first time that Andromeda was a separate, independent galaxy entirely. That discovery shattered our understanding of cosmic scale. It told us that beyond the Milky Way, there are galaxies without number. Today, observations confirm that Andromeda is racing toward us at roughly 110 kilometers per second. For decades, astronomers believed a collision was inevitable, that 4 billion years from now, the two galaxies would meet in a titanic embrace, interweave through gravitational pull, and after billions of years of slow entanglement, give birth to a vast new elliptical galaxy. But new data from the Gaia spacecraft has introduced a shadow of doubt. 100,000 computer simulations now suggest the outcome is far less certain than we once thought. Perhaps they will collide. Perhaps they will pass each other in the dark, close enough to feel, but never quite touching. The universe, it turns out, has not yet made up its mind. We leave Andromeda behind, its spiral arms fading into the dark behind us. Our next destination is closer than you might expect. 17 million light-years. A short step by the standards of what lies ahead. And yet, as we slow our approach, something immediately feels wrong. A galaxy that looks familiar at first. A spiral lit from within, turning in the dark. But something across its face is darker than it should be. We arrive now at the Evil Eye Galaxy, a spiral galaxy in the constellation Coma Berenices, 55,000 light-years across. Slightly smaller than our own Milky Way, with roughly 10 billion stars. What makes the Evil Eye unmistakable is a broad, dark band of light-absorbing dust that cuts across its bright central nucleus, giving it the appearance of a bruised eye. That dust lane is composed of carbon, hydrogen, and fine particles, veiling the starlight of the core and creating a striking visual contrast. That dust lane is composed of carbon, hydrogen, and fine particles, veiling the starlight of the core and creating a striking visual contrast. At the boundary between the two, gas collides, compresses, and ignites, triggering furious bursts of star formation, lighting the interface with glowing pink ionized hydrogen. Under the blaze of newborn stars, two disks, one galaxy, turning against each other, in a friction that will last for billions of years. Where they meet, at that turbulent seam, the universe makes new suns, conflict and creation, violence and light. We leave the evil eye behind. 29 million light years from home, we have traveled further now, and what greets us is a galaxy of extraordinary composure, ancient, unhurried, wearing its darkness like a crown. We arrive now at the Sombrero Galaxy, located in the constellation Virgo, some 29 million light years from Earth. The Sombrero stretches 90,000 light years in diameter. It is famous for its extraordinary dust lane and its brilliantly lit central bulge. From our vantage point on Earth, the galaxy tilts toward us at only 6 degrees, nearly edge-on, making that dark dust belt all the more striking. Its silhouette unmistakably resembles a Mexican sombrero. The central bulge is composed mainly of older stars, radiating a clean, bright white light. At the very heart lies a supermassive black hole, roughly 1 billion times the mass of our Sun. The surrounding dark ring is made of cold atomic hydrogen, dust, and gas, a birthplace of new stars. Waiting in the quiet dark, we circle the Sombrero slowly, watching its dark equatorial band pass beneath us. So dense, so absolute, it swallows entire star fields whole. There is patience here, the patience of a galaxy that has been doing this for billions of years and intends to continue for billions more. But patience, we will find, is not the universe's only register. We leave the Sombrero's stillness behind and climb towards something far more restless. 21 million light years, closer than the Sombrero, yet utterly different in spirit. As we approach, a face turns toward us, open, vast, and asymmetric, a galaxy that cannot quite hold itself still. We arrive now at the Pinwheel Galaxy, a face-on spiral in the constellation Ursa Major, 21 million light-years from Earth, with a diameter of 170,000 light-years. What sets the pinwheel apart is the striking asymmetry of its spiral arms. Scientists believe this may be the influence of companion galaxies, their gravitational pull disturbing it, with tidal forces again and again, shaping a complex and spectacular structure. Within those sweeping arms lie ionized nebulae and dense molecular clouds, illuminated by the fierce light of young, hot stars. As we venture inside, we find these clouds collapsing under gravity, giving birth to new stars even as we watch. The pinwheel is a stellar nursery, a cradle of creation. We descend into one of its spiral arms. Around us, great clouds of gas glow pink and violet, lit from within by stars that did not exist a million years ago. There is a restlessness here, a sense of something perpetually becoming. Stars being born in the dark, whether or not anyone is watching. We rise back through the plane of the galaxy, and the pinwheel opens beneath us like a flower. Then something shifts. The universe turns up its intensity. Our next destination does not merely glow, it burns. We are closer to home now in distance, yet what awaits us here is anything but quiet. From far away, it looks slender, almost delicate. But as we draw near, we begin to see the plumes. Red, vast, erupting. We arrive now at the Cigar Galaxy, a starburst galaxy in the constellation Ursa Major, 12 million light-years from Earth. Its diameter is only about 37,000 light-years, somewhat smaller than our own galaxy, yet it shines 5 times brighter than the Milky Way. Its central region blazes with more than 100 times the light of our galactic core. The Cigar Galaxy is the second largest member of the M81 group, surpassed only by its neighbor, Bode's Galaxy, just 750,000 light-years away, the two forming a remarkable pair across the sky. Elongated and slender, the Cigar earns its name. Its core is a furnace of creation. Young stars are born here 10 times faster than in the Milky Way, lighting up the galaxy's blue stellar disk and driving stunning red hydrogen plumes outward into space. This furious starburst was ignited roughly 100 million years ago by a close encounter with Bode's Galaxy, whose tidal forces compressed the Cigar's gas and dust, triggering star formation on a grand scale. That stellar eruption also sculpted spectacular bipolar jets, torrents of superheated gas and dust, erupting perpendicular to the galactic disk, extending thousands of light-years outward into the dark. The Cigar Galaxy is the definitive case study in starburst activity and galactic interaction. We hover above those great red plumes, columns of superheated gas, erupting from the galaxy's heart, like the breath of something alive. A single close encounter with a neighbor, and 100 million years later, the Cigar is still burning. Gravity, we are learning, leaves marks that last. And nowhere is that more evident than in what comes next. Galaxies that did not merely pass each other, but crashed. We arrive to find not one galaxy, but two, locked together, unable to separate, their arms reaching outward, like something grasping at the dark. We arrive now at the Antennae Galaxies. Located in the constellation Corvus, 45 million light-years away, the Antennae are a pair of colliding galaxies, NGC 4038 and NGC 4039. The first is the primary galaxy, the second, its companion. Both are of similar mass, each containing tens of billions of stars. Their collision began approximately 1.2 billion years ago. What were once two independent spirals are now locked in a gravitational embrace, their stars, gas, and dust pulling toward one another, forming bridge-like structures between them. Meanwhile, gravity has flung great arcs of matter outward, creating two long tidal tails. The antennae for which this pair is named. Each tail is composed of hundreds of millions of stars and vast clouds of gas, stretching hundreds of thousands of light-years into the void. In time, their cores will draw ever closer, and a new galaxy will be born. We fly along one of the antennae, that long curving stream of displaced stars arcing out into the darkness, like a wave that will never break. Beneath us, two galactic cores are drawing closer. They do not know it. Stars do not know such things, but gravity does, and gravity is patient. If the antennae show us a collision in its early drama, our next destination shows us what happens in the middle of the story, when two galaxies have already passed through each other and cannot find their way back. We slow as two elongated shapes resolve from the dark. They are pulling at each other. You can see it. Long trails of stars, stretching behind them, like something being torn. We arrive now at the Mice Galaxies, located in the constellation Coma Berenices, about 290 million light-years from Earth. The Mice are two spiral galaxies in the act of collision, their mutual gravity pulling long tidal tails from each other, tails that reach hundreds of thousands of light-years, curling like the tail of a mouse. The western tail stretches tens of thousands of light-years into the dark. Scientists believe this collision began roughly 160 million years ago. The merging process has triggered fierce bursts of star formation, especially in those long tidal tails, which are threaded with newborn stars. In the ages to come, the two galaxies will continue to merge and interpenetrate. In about 1 billion years from now, they will finally unite into a single giant elliptical galaxy. The Mice are a textbook example of galactic merger, showing us how gravity can reshape and remake entire galaxies from the inside out. We slow, and something comes into view that stops us entirely. A perfect ring, glowing, impossibly symmetrical, as if the universe drew a circle around the site of a catastrophe. We arrive now at the Cartwheel Galaxy, found in the constellation Sculptor, 500 million light-years away, with a diameter of roughly 150,000 light-years. The Cartwheel is one of the most visually extraordinary structures in the cosmos. A brilliant outer ring, a bright inner ring, a central core connected to both by spoke-like filaments. Together, the unmistakable shape of a cartwheel. The outer ring, some 100,000 light-years across, blazes with young hot stars and ionized nebulae, a wildfire of star formation. The inner ring, 50,000 light-years wide, contains older stars and little gas, its stellar birth rate quieter, more subdued. Scientists believe that roughly 200 million years ago, a smaller galaxy plunged straight through the Cartwheel's heart. The collision sent density waves rippling outward like rings on water, redistributing matter, compressing gas and dust, and sculpting that stunning outer ring. The Cartwheel is a masterclass in galactic collision. Its structure, driven by shock waves, offers us a rare and precious window into the dynamics of galaxy formation. We hover above that outer ring, watching star-forming regions ignite one by one, like embers caught in a wind. 200 million years ago, something fell through this galaxy, and the universe is still reverberating. We have spent much of this journey watching galaxies collide and tear apart. But the universe, as it turns out, is also capable of something else entirely. Something that looks less like destruction and more like beauty. As we slow, the shape ahead of us does not look like a collision. It looks like an embrace. Two galaxies, wound around each other, pulling each other into forms that have no right to be this beautiful. We arrive now at Arp Two-Seven-Three, located in the constellation Andromeda, about 300 million light-years away. Arp Two-Seven-Three is a pair of interacting spiral galaxies. The larger, UGC 1810, and the smaller, UGC 1813. Together they form what looks like a great cosmic rose. UGC 1810 is roughly 5 times the mass of its companion. Its gravity has stretched and distorted UGC 1813, pulling spectacular tidal tails and bridge-like filaments between them. Scientists believe UGC 1813 may once have passed directly through UGC 1810, a near collision that warped both galaxies further still. Their celestial dance will last for billions of years. In perhaps 1 billion years, they will merge into something larger than either. We hold our position above this pair and simply look. There are no words adequate to what the universe will do with nothing more than gravity and time. It will make roses out of galaxies. We carry that image with us as we turn toward our final destination, a galaxy that raises questions the universe has so far refused to answer. We arrive now at Hoag's object, located in the constellation Ophiuchus, approximately 600 million light-years away. With a diameter of around 120,000 light-years, Hoag's object is a rare ring galaxy, similar in kind to the Cartwheel, yet far more perfect in form. Within it burn approximately 8 billion stars. A bright, spherical central nucleus, roughly 17,000 light-years across, composed of older, redder stars. Around it, a ring of young, blazing blue stars, a region of active star formation, separated from the core by a gap that holds almost nothing at all, perhaps only the faintest trace of star clusters. How Hoag's object came to exist remains one of astronomy's great unsolved mysteries. Its structure defies our conventional theories of galactic formation. Some scientists suggest that a smaller bullet galaxy may have passed directly through the center of a larger disk galaxy, triggering the ring. But the truth remains unknown. And so our journey draws to a close. From the bruised eye of the Evil Eye Galaxy to the silent mystery of Hoag's object, these 10 galaxies have shown us the universe in all its diversity and beauty. They are not merely subjects of scientific study. They are mirrors, reflecting humanity's oldest instinct, to look up and ask why. Through this voyage, we have witnessed galaxies burning, colliding, and transforming. A reminder that the universe is never still. It has never been still. It never will be. And yet, here we are, small, fragile, temporary, looking out into a cosmos that stretches beyond all comprehension. Perhaps that is enough. To look, to wonder, to feel, just for a moment, how vast it all is and how precious it is to be alive inside it.